Okay, while this is going, first I'm going to go over homework. I got a few good emails on questions from yesterday. So I'm going to start there and then go on with multiplying and dividing rational expressions, which honestly is really easy. The hard part of that is simplifying, which is what we went over yesterday. So Amanda's here. Okay, good. Yeah, she emailed me a really good question that I'm going to go over first. And if you guys have a question, you can put the number in the chat box, and I don't mind going over it, or you can just tell me, and we can spend the first half of today going over homework questions, honestly, and because the multiplying and dividing won't take long. It's not a hard concept. We're going to spend more time simplifying once we start multiplying and dividing. So okay, let's go to the desktop camera, and then we're going to look at number 31. Okay, 31 is not the easiest question. Let me spotlight this one. This is number 31. It's on page 438. And it looks like this. We've got 9x squared minus 15x plus 25 all over 27x cubed plus 125. Okay. So the numerator here is it's a big factor, actually. So if we start, oh man, yeah, let's look at this. So 9 times 25 winds up being, let me get my calculator out. 9 quarters is what? Is that 225 times 25? Yeah. So 225. I'll write that over here, so we'll go down. So 225. And I got to multiply to see what adds up to negative 15. I don't know how we could get negative 15 at all from this. Amanda, I feel your pain here. I kind of think that middle number was supposed to be a different number.
The closest that I could get was negative 16.
Yeah. I think you're right. And I think I can manipulate this because I think I see the error that they made. But we'll see. Hold on. Yeah. 225. We know it's divisible by 5, right? That's 45. It's divisible by 25. We know that. It's also divisible by what, like 15. That's 15 and 15. How did you get 16? Amanda?
Hang on, I gotta find my work that I did yesterday.
Yeah, I looked at that. It's 25 times 9. And, both of these have to be negative, right? Oh, I see how you probably did it. The 25 and 9, but the issue is they both have to be negative because it's got to multiply to get a positive and add to get a negative, right? I mean, they did. The book, this is just wrong. The book's just not right. Hold on. The bottom does factor. So I want to check something out real fast. The bottom, this is an addition of cubes, which we talked about a little bit yesterday. It's 27, or I'm sorry, it's 3x cubed plus 5 cubed. So the bottom does factor into 3x minus 5 times, now you have to square the a, so that's 9x squared. Multiply them together, that's 15x, and then the last one is squared. Oh, there it is. Wait, no, that's still a minus sign there. Hold on. Is that where it is? Because it would be a plus sign. Hold on. Let's check that I got this factoring in the difference of cubes right. Maybe that's what it was, Amanda. Maybe that doesn't factor for a reason. It is addition of cubes, right? Oh, I got those backwards. This is a plus. There it is, Amanda. Okay. That's the, so this top doesn't factor at all. You were correct on that. But the bottom does factor because it's difference of cubes. So the top doesn't factor. But the bottom factors into 3x This is an addition, 3x plus 5, and then 9x squared minus 15x plus 25. That was the difference of cubes, or the addition of cubes on page 393. Then these cancel, and it leaves us with that answer of 1 over 3x plus 5. Yeah. Does that help a little bit?
Yep, I see where I messed up.
Okay. Yeah, my brain wasn't thinking that way at all. It was thinking that we would have to cancel, or we'd have to factor that numerator. But any other questions? We're going to be doing a lot of this today, just with the addition of multiplication and division of rational expressions. Okay, cool. Let's keep going. So again, the concept of multiplying and dividing fractions shouldn't be hard. That's not the hard part when you're dealing with fractions. Like if we go back in time, whenever you learn this, I'm going to kind of show you how we're going to do it actually with these rational fractions. So it might be a little different than just with numbers. So if I had, like, let's say 4 over 5 times, let's say 6, and we'll put a 1/6 up here, right? If I want to multiply these, really you just have to multiply across. But what I do with whenever we deal with actual expressions is I factor the numbers completely. Okay. So the 4 factor turns into 2 times 2, right? And then I'm going to multiply it by the 1. Now we don't have to put that. I'm just going to put it because that's what we're doing. Remember, fractions you multiply across. 5 is just 5. It doesn't factor. But 6 factors into 3 times 2, right? And then just like before, we're going to cancel what has a common factor. Those 2's cancel, right? I can't cancel anything else out because nothing pairs up. So the top becomes 2 times 1, that's just 2. And on the bottom, we have 5 times 3, which is 15. Now, look, I'll tell you, in these expressions, I think this book leaves them factored. Whoa. Let me see before I just tell you something that I'm making an assumption on. Yes, it leaves them factored. So it would actually leave the bottom as 5 times 3. I know that looks goofy with numbers. It'll make more sense once we get to the actual fractions, the examples for this section. So that's all we're going to do. I'm going to factor I'm going to factor each component completely and then just multiply it across. It's really kind of straightforward. So if we looked at, let's say, I'm going to steal this one from you, but if we looked at 3n plus 1 over 2n times 2n minus 4 over 3n squared minus 2n minus 1. Okay, the very first thing I'm going to do, though, is put parentheses around anything that's in a numerator and denominator. It cleans it up and it makes it just easier all around. And if you don't put those parentheses, you're going to wind up multiplying something that shouldn't be multiplied. Okay. And then I'm going to look at every single set of parentheses and I'm going to factor them completely if they can be factored. Like if we look at this first top left parentheses, there's nothing that can be factored. 3n plus 1, there's no common factor. So I'm good there. 2n, same thing. Nothing factors. It's a single term. So nothing factors out of a single term. So now I'm going to go to this top parentheses and I see that something does factor. 2n minus 4, I can factor a 2 out here. Okay. So now look, I'm going to combine these as I go. So this is going to turn into 3n plus 1 times, because we're multiplying across, 2 times, because I factored the 2 out, in minus 2, right? If I factor a 2 out of 2n minus 4, it becomes n minus 2. Okay, and everything's just being multiplied. Really, what we have up here are 3 different numbers, just like if it was 5 times 3 times 2, right? They just don't look like normal numbers because They're binomials, they're two binomials. So this is like saying 5 times 2 times something else, okay? So, but we have three distinct numbers here. They're all being multiplied, which is what we need if we're gonna cancel them with anything in the denominator, okay? Now in the denominator of this fraction, I gotta factor this guy out. So I'm gonna do it on the side over here. Let's say we've got 3n squared. If I multiply the 3 times the -1, I get -3. Man, I'm running out of room. This marker's a little fatter. So that's -3 times 1 would give me the -2, right? So 3n squared minus 3n plus 1n minus 1. This is just factor by grouping. You should have done this a lot by now, or however you like to factor. You should have this down almost as a reflex. So parentheses around the first two and last two. I need to factor a 3n out of the first term. Leaves me with n minus 1. I don't want to change this second term, so I'm going to just factor a 1 out. Then it becomes n minus 1. These pair up. I factor them out, and I'm left with, I factor the n minus 1s out, and I'm left with n minus 1 times 3n plus 1. So again, look, this should look really familiar to everything we've been doing in 6.1, which is really familiar to everything we were doing in like the end of chapter 5, right? Okay, so now let's write what all of this is factored out. So I'm going to come back here. 2 times n, I'm going to write that separately, okay? That's 2 times n times these two factors now. N minus 1 times 3n plus 1, okay? I've got 4 separate factors. I've got the 2 and the n. Those are factors because they're being multiplied. Times because we're multiplying these fractions across. The both of the factors from this trinomial, 2n minus 1 and 3n plus 1. And then we're just going to see what cancels, what goes away, right? I'm going to take my red marker out. Right away, I can see the 2's go away. You guys see that? And then the 3n plus 1's go away, right? And then that's it. I can't cancel out the n minus 2. That's an n minus 1. These are two totally different numbers. So the numerator would be n minus 2. The denominator, don't forget that n there, would be n times n minus 1, right? Now, this is where your book stops. And there's nothing wrong in stopping it there. If you're like, no, I have to distribute the n because it doesn't feel right, you're more than welcome to distribute this. If you distribute the n through, it winds up being n squared minus n. And there's nothing wrong with that, but I'm going to tell you, we're going to leave these in factored form for things we do later on, okay? We're going to like simplify it more later on or manipulate it later on, and we want them in factored form. It helps us out a lot in factored form. So I'm going to kind of repeat the steps here that I did, but go over this question. So the first thing I'm going to do when I'm given a multiplication is factor everything completely, okay? So the 3n plus 1 couldn't factor. 2n minus 4, I factored the 2 out, left me with n minus 2. 2n I couldn't factor. This trinomial, though, I did factor. So I'm going to factor everything completely and then multiply it across because it's multiplying fractions. Then I'm just going to see what cancels. And what all is left over is your answer, okay? It's that kind of straightforward. So really, we're simplifying fractions. That's all we're really doing, okay? That's all we're really doing. You guys have any questions before I just do about 40 examples? Okay, sweet. Let me steal one from the homework that might be honestly easier. Hold on. Okay, yeah, this one looks a little easier. We'll see. I'm gonna have to do some trick to get it to go. This is 34 in the homework on page 439. Okay, number 34. We've got 10 minus 2x. I'm gonna put it in parentheses right off the bat. Over 7 times 14 over 5x minus 25. Oh, good. I'm glad we're doing this one. It's a little different than the one before. Okay, so we've got 10 minus 2x over 7 times 14 over 5 minus 25. So again, I'm going to do the same thing I did before. I'm going to factor what I can factor out and then see if we can cancel anything out. Okay, So in this first fraction, I can factor a 2 out. Do you guys see that? So I'm left with 5 minus x times 14, right? Because there's 14 over here. Over, now I've got the 7 there, times, and with this fraction, 5x minus 25, I can factor a 5 out. And I'm left with x minus 5. Okay, I don't know how you learned how to simplify fractions, but I'll tell you, the 14 and the 7, those will cancel, and it's going to leave me with a 2, right? So I can cancel the 14 and the 7 together, but that leaves me with a 2 up top, because 14 divided by 7 is just 2. So let's kind of see what we have going on now, because it doesn't look like anything matches, right? 5 minus x is not the same as x minus 5. 2, we got a 5 number on bottom and a 2 on top. So I'm going to multiply the 2 and 2 together. Gives me 4, right? That's this 2 and the 2 left over from 14 divided by 7. And on the bottom, I'm left with 5 and x minus 5. Okay. Any questions? I'm going to pause here. We're not done. There's one little trick that you can hopefully see that we went over yesterday. But are there any questions about what I did up here? In the end, I factored these two completely, right? And then we multiplied across. Really straightforward. Okay, hopefully you see this. 5 minus x and x minus 5. The only thing different is the order around the minus sign. And there was a rule that we learned that said if we factor out a negative, we can flip around a difference, right? Around a subtraction. So I'm going to do that with the numerator. I'm going to factor a negative out, so it becomes negative 4. And then this makes the binomial x minus 5. If you don't remember that trick, it's in a previous lecture. Did we go over that yesterday? Yeah, okay, it was yesterday's lecture. So it winds up being negative 4 times x minus 5 over x minus 5. And hey, now we have matching parentheses. And this goes all the way down to negative 4/5. Kind of neat, okay? Negative 4/5. Questions? Questions, comments. Okay, let's keep rocking, moving forward. Let me steal one. I want you to try one that's kind of in this, like these actually. So give me just a second. I'm going to find one for you that I like. Yeah, okay, try this one by yourself. I'll give you a few minutes. We've got 2x minus 3 over 5x times 5x plus 5 over 2x squared minus x minus 3. Okay? So try this one. It's just a practice problem in the book. So now I'm going to tell you right off the bat, make parentheses around all of this. Okay? I'll give you a few minutes. Just keep rocking and rolling. See if we can get to this. Okay, so let's start rocking and rolling on this one. So I've got, actually, I think this fraction doesn't simplify at all, right? It's the second fraction. So I can factor a 5 out of here. I've got to factor this trinomial. So I'm going to do that on the side over here. So 2 times -3 is -6. That's got to be -3 and 2, right? To add up to -1. So I'd get 2x squared minus 3x plus 2x minus 3. Factor the x out. I'm left with 2x minus 3. Need to factor a 1 out because I need the same. So that trinomial factors into 2x minus 3 and x plus 1. So if I work this across, 2x minus 3, I'm going to factor a 5 out of this parentheses. So that's x plus 1. On the bottom, I've got 5 times x times these two factors now, right? 2x minus 3 and x plus 1. Hey, everything's going to go away in the numerator. Check this out. 2x minus 3 goes away. X plus 1 goes away. 5 goes away. The only thing left here is an x in the numerator. So the only thing left is a 1 up top. Because remember, if everything goes away in the numerator, you have to have a 1 and an x in the denominator. Boom. Shakalaka. Okay? Any questions? Comments or concerns? Great. Okay. I mean, well, not great if you have a question you're not asking, but I'm going to assume you all are understanding this to the point where you can start attempting the homework, right? I mean, that's the thing. I know you might not get it yet, but once you get in the homework is really when you hammer down the understanding. Let's go on to division because it doesn't really add anything. There's only one extra step, and then we'll just do a ton more examples, okay? So if you don't remember how to divide fractions, let's go over this for a second. So let's say I had 4/5 divided by, let's say 8/15, okay? If you wanted to divide fractions, there's kind of this old like adage that says keep, change, flip. You keep the first fraction, you change the division to multiplication, and you flip, you do the inverse of the second fraction, okay? 15/8. So now I am going to finish this one the way we've been finishing the ones before, the way we've been completing these fractions where we just factor everything completely. 4 is 2 times 2. It's multiplication now, so you go across. 15 is 5 times 3. 5 is just 5. 8, though, is 3 threes, I'm sorry. 3 2s. That's what I'm trying to say. Whew, feels like a second Monday. It's not good. Okay. Then we just cancel what cancels, right? 5s cancel. This cancels. This cancels. I'm left with 3/2. Okay. I'm left with 3/2. So the only thing different, look, in one step, it turns into multiplication like we've been doing before. Okay. So in one step, this just turns into a multiplication problem. And that's how I work these. There's probably some other trickier way to do it, but that's how I do it. I just make a multiplication and then I work them like we've been working before. So if we looked at an example, I'm stealing this one straight from the homework. Let's say, excuse me, actually I'm going to change it up a little bit. If we had 12y cubed over 5y squared minus 5 divided by 6 over y minus 1. So I'm going to put parentheses around everything before I do anything, okay? And the very first thing I'm going to do with this is I'm just going to make it multiplication, and I'm going to do what we were doing with every other example previous, okay? So the very first thing I'm going to do is say, well, this is actually keep the first fraction the same, and then flip the second fraction. So this becomes y minus 1 up top and a 6 on the bottom, right? Pretty straightforward. So if we look at each one of these, now if you want to put these in parentheses, that's fine. But if we want to look at each one of these, look, the only thing that factors is going to be this bottom left parentheses, right? We got 12y cubed. One term's not going to factor. Same with the 6, right? That's just single terms. Y minus 1 doesn't factor, but 5y squared minus 5 is going to factor a few different ways, actually. So the first thing I could see is we factor a 1 or a 5 out, right? I'm going to factor the 5 out. And they get 5y squared minus 1. Then, look, guys, and I know this is tricky, but this is a difference of squares. You see that? It's y squared minus 1 squared. So this turns into y minus 1, y plus 1. Holy cow. Okay, so let's see what we've got going on now. So we've got the 12 times the y cubed times the y minus 1, right? That's the numerator just multiplied out. Over, now this binomial factored into these 3 separate terms. So 5 times y minus 1, hey, that's going to cancel. Y plus 1, and then we've got this 6 over here, which is going to cancel with the 12, right? So we kind of expanded it out to simplify. Actually, yeah, we factored it out to simplify. Okay. And then I'm just going to go through with my red marker. And I'm going to cancel everything I know that cancels. I see the y minus 1. This 6 in that 12 is going to turn into a 2, right? I think that's it. Look, we got y cubed. There's no y's down here. That's a y plus 1. Remember, we can't cancel a parentheses with a single term. That's why I make these parentheses, okay? I can't cancel this y cubed with that y because it's inside of parentheses. That's one of the reasons I do parentheses from the very beginning. And then we got the 2 and the 5. So yeah, we're done. So this turns out to be the numerator is 2y cubed over 5 times y plus 1. Okay. Questions, comments, concerns? I'm going to give you a few now because really all you have to do is flip that second fraction and it turns into multiplication, right? So I'm going to give you kind of a mixed bag here and have you work these out. I've got my markers all mixed up. Sorry on this side. Okay. So I'm going to go straight to your homework. Actually, I lied. Now these are going to look rough because they're going to take a while to factor. Okay. The examples we've done so far, the factoring hasn't been too bad. But I've noticed with this book, what she'll do is to make things more difficult, she'll just make it where you have to factor everything completely. Okay. So this is number 40. Let's put this with 2 right here. Give myself two sides of this paper. 40 is x squared minus 3x plus 9 over 5x squared minus 20x minus 105 times x squared minus 49 over x cubed plus 27. Okay, so again, the first thing I'm going to do is put parentheses around everything. And then I want you to work, we'll pause here. I want you to just work this one, and then we'll do a division after this. So this is a doozy, to say the least. Try that one. Okay, keep going. I'm going to get started on this. I don't think this first one simplifies. So I'm going to stop. I'm not going to factor that one. Let's look at this denominator here as a monster. Okay, so we've got, I can factor a 5 out. 5 divided by, that would be, is it 26? That doesn't sound right. 21. Okay. And then so that denominator factors into -7. Ooh, that's out there. And then +3. So that's the denominator here. The x squared minus 49 is difference of squares. So that's going to be x minus 7, x plus 7. That's a difference of cubes. So I'm going to go back to that page in 5.6 to make sure I don't mess this up. Remember, I'm not going to put one of these on the test. That's a difference of cubes. But if I did, you can use your book, okay? Because this is x cubed plus 3 cubed. So that winds up being the difference of cubes. So I'm going to add them together, x plus 3. Square the first, minus, that's a minus sign. That's going to cancel right there. And multiply those together, 3x. And then square the b, so that's 9. Okay, so if I'm going to write this out factored, which I shouldn't have cut my page off here. This is actually, you know what? Let's use a tighter marker. I think this one will be a little tighter. So we'd have x squared minus 3x plus 9. Can you guys still see that? Yeah. Times x minus 7 times x plus 7, right? That's the numerators. The denominator, now this first denominator is right here. So 5 times x minus 7, x plus 3. And the other denominators is difference of, or addition of cubes. Holy cow. X squared minus 3x plus 9. Okay. Whew. Okay, so let's take out the red marker and start just slashing. This does cancel with this, that leftover addition of cubes trinomial. We've got the x minus 7 canceling. I think that's it. Okay, so that leaves me with, let me make sure. Let me get back to this section. The numerator, I've got x plus 7. But in the denominator, I've got 5 times. Now, I'm going to be lazy and write this as x plus 3 squared, right? Because you're multiplying 2 of them together. So that's just x plus 3 squared. Yeah. That is the simplified fraction, or multiplied fraction, then simplified. Whew, that was a lot, right? And really, the hard part of this isn't multiplying. Multiplying, that wasn't a big deal. The hard part of this is factoring all 3 parts of these, right? And that's what you're going to see. Really, 6.1 turns into a beautiful section on reviewing factoring skills, okay? A beautiful section on reviewing different factoring skills. Okay. Any questions about that one other than, holy cow, these really, that escalated quickly, right? Okay. Okay, let's look at another. Now I'm going to sneak down over here to the division stuff. This is number 52 in division. So, man, I'm going to probably need a whole page. I don't know. I know I'm not making a line down the middle again. So this is 52. Let me use that other marker. I'm trying to use it up. 52 is x squared minus 4, and automatically I'm going to put parentheses, over 3x plus 6, divided by, remember we're going to just flip these right off the bat. 2x squared minus 8x plus 8 divided by x squared, is it plus 4x plus 4? Let me make sure I got this right. X squared minus 4, then 3x plus 6 divided by 2x squared minus 8x plus 8, and then x squared plus 4x plus 4. Yeah, so try that one. So try this. This is number 52 on page 439. So I'll give you a few minutes. Again, Remember to flip it. And if you, I would flip it on the first step and then just simplify all of them. All of these are going to factor. Okay, keep working. I'm going to start factoring all of these, right? This is crazy. All four of these are going to factor in some, I think are going to factor in some way, shape, or form. Sneeze. Oh, guess what do oh, there it is. Oh, that felt good. Okay, so top left, we've got x squared minus 4. That's going to factor into x minus 2, x plus 2. Okay. The bottom left, that's, I can factor a 3 out, that's x plus 2. The top right, which is going to become our bottom right, I can factor a 2 out. That leaves me with x squared minus 4x plus 4. This factors into -2 and -2, right? X minus 2, x minus 2. So right now I've got this one, and that one. Now this guy is going to factor into x plus 2 times x plus 2, okay? Whew. So I'm going to write this out now. I think this marker is just cashed out. I'm going to write this out now with it being factored, but I'm also going to flip it at the same time. So the top left is going to stay the same, x minus 2, x plus 2. The bottom left, I factor the 3 out, and I'm left with x plus 2, right? Times, now look, this is going to be up top now, right? This bottom one. So this bottom one factored is down here, x plus 2 times x plus 2. All over now, I factored a 2 out, right? X minus 2, x minus 2. Now look, everything's being multiplied. You can just put multiplication in between all of this. So at this point, you can just start canceling with top and bottom. So let's see, this x minus 2 can go with that x minus 2. This x plus 2 can go with that x plus 2. Is that it? I think that's it. So on the top, again, we're left with x plus 2 times x plus 2. So I'm going to write it as x plus 2 squared just because it's a little cleaner. And we got a 3 and a 2 we need to multiply together. So that's 6 times x minus 2. And that's our simplified fraction, okay? Any questions? Comments or concerns? I'm trying to see. There's another one that I'm like, man, this one's totally different. I'm gonna have to. Yeah, let's do 58. Okay, 58 is probably like the last one we'll do, and then we'll just call it a day. I'll give you the homework. 58 is a challenge. I'm going to tell you that from the get-go. It's a challenge. It's got a difference of cubes, so you might have to go back to 5.6 and look that up, but this is 58. X squared minus 3x over, now here's our difference of cubes, x cubed minus 27 divided by 2x over 2x squared plus 6x plus 18. Okay, so I want you to try this one. I'm going to give you a few minutes. It's a good challenge. If you can get like halfway or like 75% through this one, I'm going to tell you you're on the right track. Okay, it'll just take more homework questions. I got soothing background music for examples. Put you in the zone. Get to your Zen place. You're not in developmental math 2 or developmental algebra 2 at 8:45 a.m. You're relaxing on a beach at sunset. Feeling those cool breezes off the ocean. Nope, back to reality. You're in math. Okay. So let's look at this one now, guys. And again, the same thing from before. I'm going to factor each one and then kind of put them back into it. Okay. So x squared minus 3x, I can factor an x out. So you know what? Maybe I can just write these as I go. So this would be x times x minus 3. On the bottom, this is difference of cubes. So I'm going to look that up again, honestly. 5.6. I know it's x cubed minus 3 cubed. So if I go back to 5.6 and I go back to that rule on page 393, this would be x minus 3 times x squared plus 3x plus 3 squared, so 9. Ooh, so that's the first fraction. Times, now I'm going to flip this fraction, right? I can factor a 2 out. Okay, this is going to be like a 2-step one, so I'm going to do it on the side over here. If I factor a 2 out, I'm left with x squared plus 3x plus 9. Well, that doesn't factor. Hey, it's going to cancel down here, right? Sweet. Okay, so I'm going to leave that. So times 2 times x squared plus 3x plus 9 all over. Now this one goes to the bottom. Okay. Now, guys, this is all multiplied together. You can cancel at this point. If you're like, no, I have to have these all written as a single fraction, you can do that. This is a wasted step, but you're more than welcome to just write these all together because they're being multiplied, right? X minus 3, x squared plus 3x plus 9 times 2x. And then I'm just going to go through and start marking everything out that marks out, right? So I'm gonna mark out everything out that cancels out here. Okay, so x cancels with the x. Oh, 2 cancels with the 2, right? X minus 3 cancels with the x minus 3. And then the trinomial cancels with the everything goes away, right? Everything is bleeding. Everything dies. Okay, everything goes away. If it all goes away, we're just like when everything went away with the numerator, really we're left with a 1. What this means is we really have 1 over 1. So we're left with 1. The answer is 1. This, what we started with, is really just a 1. It's a really complicated way to say 1. It's very mean of this author, Dr. Martin Gay. You can email her. She's still alive, I believe. Okay. Okay, for homework though. So really what I want you to now do is finish up this section. And you'll notice it's just a review of factoring. A major review of factoring. So let me get to the page. I'll give you all of it. So let's say we've got, this is page 439. Okay, so it starts on number 33. And then I want you to do 33 through until they start combining all kinds of weird stuff. Yeah, 33 through 63 odd would be perfect. And if you want to do the evens, because you just want to, you're just maybe not grasping it or feel like you need more more practice, you can do the evens for those 33 through 63 as well. And nice, Jared. 33 through 63, and you'll be fine. I don't mind going over any answers to even problems because I don't think you guys have those in the back of the book. You guys only have the odds, right, Janie? Give me a thumbs up if I'm right. Okay, cool. Okay, so any other questions before we end today's lecture? I can't think of any like housekeeping things going on for now. Okay, I think we're good to go. Okay. I'll see you guys. I'll stick around on here if you want to stick around and ask questions for a little bit. I'm going to turn off YouTube Live